Namaste. Welcome to today's class, Subject Science and Technology, Grade 10, Unit 14, Classification of Elements. We are here with the lessons of this Unit 14 about classification of elements. Dear students, let's discuss what is classification of elements, how elements are classified. Before that, I am going to present a flow chart about the matter. Do you know what is matter? Yes, the things, substances around us are called matter. Then how are matter classified? The matters or substances are classified into mainly two things, two parts: pure matters or pure substances and impure matters or impure substances. Do you know what are the pure matters? Yes, pure matters are further classified into elements and compounds. Similarly, impure matters are the mixture. Do you know what are the types of mixture? Yes, mixture also can be classified into homogeneous mixture and heterogeneous mixture, which you have already learned in the previous classes. Now, let's discuss about the elements. Do you know what are the elements? Can you name some of the elements? Sure. Iron, copper, gold, silver, oxygen, hydrogen, nitrogen are the different type of elements. And elements are three types based on the physical structure, physical composition: solid, liquid and gaseous state, isn't it? Iron is solid, gold, copper are solid, but oxygen and hydrogen are gaseous elements. And few elements are there which are in the liquid state. Can you example one liquid state element? Yes, the mercury is liquid element which is used in the thermometer liquid, isn't it? Dear students, regarding the classification of elements, matter exists in the pure and impure form in the nature. So, within the matter, the elements are classified by the different scientists. One example, one activity about the classification, I am going to demonstrate you. Dear students, how are elements classified? How are matter classified? Let's proceed one activity, isn't it? Here are some of the items of different characteristics. Look at it. These magnetic cubes have the different characteristics. And can you classify them? How to classify? We can classify based on the certain features. Our classification feature is color. Look at here. First of all, we can classify according to color. This is one group. Second group, we can classify according to this color, next color, red color, green color. This is one class, this is another class. Another classification is, look at here, as per next color, that is orange color. Then this is separate color, it is next separate color. So these are categorized. Substances are categorized like this according to their characteristics. So scientists tried to classify elements based on their features, characteristics, chemical properties, physical properties and so on. Like this, we have done this simple activity about the classification. So, the elements are classified into different category. Do you know, in the ancient Greek philosophy, elements were four types. They are fire, air, earth and water. But in modern classification, elements are classified into different categories like solid, liquid, gas, metals, non-metals, metalloids, reactive element, less reactive elements, isn't it? So different category of the elements are proceed. So before discussing about the classification, formally how elements are classified, we have to discuss about the background or foundation for the classification of element. Look at here, this is one element which element you try to identify. And talking about the background, till now there are altogether how many elements? 118 elements have been discovered so far, with 92 elements are natural and 26 elements are artificial. They are artificially discovered in the lab by the scientists. Each element is composed of same type of smallest particle called the atoms. You know, each element, for example, gold is one element. So gold is composed of very small particle. This is a piece of gold, and this gold is composed of same type of particle of gold, isn't it? So this every particle of gold is termed as atom. Not only gold, oxygen has also same. So every gold atom has symbolized as Au, because they are the particle of gold. So particle of gold are considered particle or atom. Those elements have the same type of particle called the atom. Some element have the similar physical and chemical properties, while the other have the different. Suppose oxygen and hydrogen have different physical properties and chemical properties, but oxygen molecule, oxygen atom have the similar physical and chemical properties. Similarly, some of the metal have the similar chemical properties like lithium, sodium, potassium, so that they are placed in a single group. Non-metal like fluorine, chlorine, bromine, iodine, they have the close characteristics to each other, similar properties. Because of that, they are placed in one group, isn't it? So during 19th century, only 63 elements have been discovered during the time. That time was the time of Mendeleev. Do you know Mendeleev's periodic table and Mendeleev's classification? We are going to review in today's lesson. Over the time, new elements were identified, leading to an increasing number of elements, and that made the study and research work challenging. Let's discuss again. Over the time, new elements were discovered. So if the number of elements were increased, then it was difficult to study all the elements easily, and it was difficult for the research work. So scientists realized to classify the element based on their characteristics to facilitate scientific study and research accessible. So here is one element. Do you know? There is 10. 10 means, here is written neon. Neon means any symbol represent the neon. So it is the atomic model of neon. So this type of atomic model you have already studied in grade 9, 8, previous grades. So we don't discuss about the atomic model, because we are going to how elements were classified. So we are talking about the historical background about the classification of elements. Here is one portrait. Whose portrait is it? This is Mendeleev. Do you know? The Russian scientist Mendeleev. So before the time of Mendeleev, what attempts were done by the different scientists? Different scientists, different chemists have their contribution in the classification elements. In 1829 AD, I.W. Dobereiner proposed triad rule, that is called Dobereiner triad rule. We don't go detail what is Dobereiner triad rule. You can search internet and you can study for the detail. You will study about this in higher classes. Similarly, in 1865 AD, John Newland proposed octave rules. So that is called Newland's law of octave. It is similar like the octaves of music: sa, re, ga, ma, pa, da, ni, sa. Sa repeated to sa. So that type of properties were discovered by the Newland, isn't it? Similarly, in 1869 AD, Lothar Meyer proposed atomic volume. Volume means V equal to atomic volume. That is the mass per unit density, mass upon density is called volume, V equal to m by d, d equal to m by v. So, V equal to m by d, that is volume means mass per unit density. It shows a curve model, so that in the curve the peak position was observed for the highly reactive elements. That also you will study detail in higher level. In 1869 AD, Russian scientist Dmitry Mendeleev proposed a periodic law based on the increasing atomic weight, that is atomic masses, and prepared a tabular form of element. What is that called? Yes, that tabular form of element is called the periodic table, and we understand, we recognize it as Mendeleev's periodic table, which was the first attempt in the classification of elements scientifically. After classifying element into different groups and subgroups, Mendeleev prepared this table. And what is the Mendeleev's table look like? We will discuss about Mendeleev's table. So, Mendeleev's periodic table is based on the Mendeleev's periodic law. Do you know what is Mendeleev's periodic law? This is the statement of Mendeleev's periodic law. The physical and chemical properties of the elements are the periodic functions of their atomic weight. Periodic functions of their atomic weight. It means that if the elements are classified according to increasing atomic weight, atomic mass, then properties of elements are repeated after certain interval. Properties of elements are repeated after certain interval. Let us see one example. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. After fluorine, in Mendeleev's table, it repeats sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. After chlorine, there is repetition of the element potassium. I say, why repetition? Look at it. This lithium, sodium, potassium fall in a same group. Similarly, fluorine, chlorine fall in a same group. Look at it. Here is periodic function. Periodic function means 1, 2, 3, 4, 5, 6, 7, 8. Eighth element's property is similar to the first element. First element and eighth elements resemble in their properties. This is called periodic function. So, it was classified according to increasing atomic weight, atomic mass in the Mendeleev's periodic table. But later on, this rule based on the Mendeleev's periodic table demonstrated so many complexities, difficulties, so it was remodified to modern periodic table. Now, let's observe what was Mendeleev's periodic table look like. This is Mendeleev's periodic table. It was a short form of periodic table. Check it here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertical columns. These vertical columns are groups. Yes, 8 groups. Similarly, there are horizontal rows also. Look at it. 1, 2, 3, 4, 5, 6, 7. 7 horizontal rows and 8 vertical columns are there in the Mendeleev's periodic table. This periodic table was the first attempt in the scientific classification of the element. So, let us discuss about the features of Mendeleev's periodic table. There were only 63 elements discovered during the time of Mendeleev. So, this table was also in small form, short form, because elements were not more in number, only 63 were accommodated. So, properties of element are repeated periodically. Just I have presented that lithium property is repeated to sodium, sodium property repeated to potassium, because it is based on the periodic classification. So, periodically properties are repeated up in first period to second, second to third, and so on. So, elements are kept in 8 groups. 8 group means vertical column. Vertical column are groups which are here in the model of periodic table, and these groups are group 1 to group 8. Look at it, group 1 to group 8. These are vertical column. And 7 periods. 7 periods are the horizontal rows. The period 1 to period 7. Period 1 to period 7. These are horizontal line, horizontal rows of the elements. And these horizontal rows were developed according to increasing order of atomic weight, atomic mass, isn't it? Vertical column were formulated according to the similar characteristics of the elements. Suppose in the group 7, fluorine, chlorine, bromine have the similar characteristics. They all have the valency 1. They are non-metal. They are highly reactive non-metals. Yes, this is the basic foundation, fundamental features of the periodic table. And elements with the similar properties were placed in the same group. Elements having similar properties were placed in same group in the Mendeleev's periodic table. But there are some of the forecasting by the Mendeleev for the future elements, so that Mendeleev placed some of the gaps in the periodic table. Why gaps were left? These gaps were left for the future element which would be discovered in the future. Yes, this is a table. Here are the features of some of the elements which would be discovered in the future, and Mendeleev proposed these elements are named with the gap in the Mendeleev's periodic table. Look at here, this red color place are the gaps which were left by the Mendeleev's for the future element. Look at here, element which look like boron, isn't it? Character similar to boron was proposed as Eka-boron, and it was discovered scandium, isn't it? The name of the discovered element was scandium 21Sc, which was placed in the same gap. And another forecasting was like aluminum element which would be discovered in the future, whose character looked like the aluminum, that was named as the Eka aluminum, and it was discovered gallium. Gallium was discovered and placed here in the gap. Similarly, element whose character looked like the silicon was proposed as Eka silicon, and the germanium was discovered. Germanium element was fulfilled here in the gap. Yes, these are some of the features of the Mendeleev's periodic table. Now, let's talk about the modern periodic table. Before talking about modern periodic table, why modern periodic table formulated? What is the reason behind it? Yes, does Mendeleev periodic table fulfill all the characteristics of the elements? Here are the some demerits. Demerits or weaknesses of the Mendeleev's periodic table. So over the demerits, modern periodic table was proposed. What are the demerits? Let's discuss. Many complexities or demerits had been mentioned in the Mendeleev's periodic table. So some of the demerits are here. Look at it. First demerit is position of isotopes. Do you know isotopes? Here are given symbol of the element. Look at here, 6C12, 6C13, 6C14. What do you understand by this symbol? Yes, this is carbon isotope. Do you know? Isotopes of carbon. Isotope means element having same atomic number. Look at it, same atomic number. Carbon atomic number is 6. But atomic weight is different. Atomic mass is different. Carbon 12 means here are 6 proton and 6 neutron, isn't it? 6 neutron. So its atomic weight is 12. Here are 6 proton but 7 neutron, isn't it? So its atomic weight is 13. Here are 6 proton plus 8 neutron. So that atomic weight is 14. Similarly, do you know 1s1, 1s2, 1s3. Look at it. Which element is it? Hydrogen. Hydrogen has also 3 isotopes. Atomic number 1, atomic weight 1. Atomic number 1, atomic weight 2, 1 proton, 1 neutron. It is protium, it is deuterium, this is tritium, isn't it? Atomic number 1 but atomic weight 3, that is 1 proton, 2 neutron. So, neutron number can be different in the nucleus of the atom of element that develops the isotope. But Mendelev's periodic table could not explain about the position of isotope because Mendelev's periodic table was based on the increasing atomic weight. If atomic weight are increasing, then hydrogen should be placed in 3 places, no? But Mendeleev could not give the place. Carbon has 3 isotopes. Mendeleev could not give extra place for the carbon to accommodate isotopes of the carbon. So here is the defect. Yes, we are clear about the isotopes of the elements whose position was not given in the Mendelev's periodic table, and in some cases chemically similar elements were placed in the same group, isn't it? Here is a table, look at here, hydrogen, lithium, sodium. With the sodium, look at here, here is copper also, silver also, gold also. Copper, silver and gold, and lithium, sodium, potassium. Do their characters similar? Do their character have similarity? No, they are different characteristics. Lithium, sodium, potassium, highly reactive metals, soft metals, but iron, copper, silver, gold are less reactive metals, but these are placed in a same group. This is defect in the Mendelev's periodic table. Position of hydrogen was not fixed. Hydrogen atomic number is 1. It was placed in group 1 in the Mendelev's periodic table, but its characteristics are similar to group 7 also because its valency is 1. It gains 1 electron like group 7 elements, fluorine, chlorine, isn't it? So it is also considered as defect. Anomalous pair. There are some anomalous pair, unusual pair. Some elements with the greater atomic number are placed earlier than the element with a less atomic number, which fails the Mendelev's periodic law. Look at here, copper, cobalt and nickel. Cobalt atomic weight and nickel atomic weight. Look at here, here is the difference. Cobalt has higher atomic weight, but it is placed earlier, and nickel has low atomic weight, which has placed later. Same type of complexity is seen in the argon and potassium. Look at it. Argon has atomic weight 40, potassium has atomic weight 39. So this type of pair are anomalous pair, which is also demerit or complexity in the Mendeleev periodic table. Position of lanthanides and actinides was not fixed, isn't it? Lanthanides and actinides are the different elements whose characteristics are not mentioned, position was not given. So after detailed study, scientists realized the atomic weight is not the base for the fundamental properties of the elements. That means Mendeleev's periodic table was not fit, was not enough to explain detailed properties of the elements. So what happened then? After the study of demerits, weaknesses of the Mendeleev's periodic table, scientists proposed new periodic table, isn't it? In 1913 AD, English scientist Henry Moseley formulated modern periodic law and developed modern periodic table, which was based on the increasing atomic number, not the increasing atomic weight. Now, what was the modern periodic table look like? Henry Moseley proposed modern periodic law. It was based on the atomic number, that is increasing atomic number, to develop the modern periodic table. Atomic law, this modern periodic law states that physical and chemical properties of the elements are the periodic function of their atomic numbers. This only one word is different in Mendeleev's periodic law and modern periodic law, that is atomic weight was given in Mendeleev's periodic law, atomic number is given in modern periodic law. So based on this periodic law, this type of element this type of periodic table was formulated. This portrait is of Henry Moseley, who proposed this type of periodic table, which was in the long form of the periodic table. So, this periodic table is considered as the long form of periodic table, which is the modern periodic table. It was developed on the basis of increasing atomic numbers, that is hydrogen atomic number 1, helium 2, lithium 3, beryllium 4, 5, 6, 7, like this in the serial order, increasing atomic number. The element with the similar properties are kept in the vertical column called group. This vertical column are group, and horizontal rows are the period. That means element with the increasing atomic number are placed in a same period. Look at here, this is period 1, this is period 2, period 3, period 4. Let us discuss about the main features of the modern periodic table then. Main features or characteristics of modern periodic table are here. Elements are arranged in the increasing order of atomic number. That is the first main feature of the periodic table. There are altogether how many groups? 18 groups. 18 groups. Groups means vertical column, isn't it? And 7 periods. 7 periods are the horizontal rows which were given in the Mendeleev's periodic table too. But in modern periodic table these are modified. In Mendeleev periodic table there were only 8 groups, but here 18 groups. How groups are divided then? Groups are further divided into A and B subgroups based on the IUPAC system. Do you know IUPAC, full form of IUPAC? IUPAC system means this is International Union of Pure and Applied Chemistry. Yes, this is the international union who proposed new rule, new theories in the chemistry. So, this periodic table was proposed by IUPAC system. Now, here is one model of the modern periodic table. Look at here, group 1, 2, 3, 4, 5, 6, 7, 8. Altogether, how many groups are there? 18 groups. Look at here. This vertical column are 18, and these groups are further divided into A and B subgroups. Look at here. Group 1 is 1A, 2A, then 2A. Then after here is 3A, 4A, 5A, 6A, 7A, and 0. This 0 group was previously called 8A. Now it is 0, because in 0 group there are helium, neon, argon, krypton, xenon, radon. All the elements having 0 valency are placed there, isn't it? So, these group A elements are normal elements, representative elements, and here are the group B. Look at here, 1B, 2B, 3B, 4B, 5B, 6B, 7B, 8B, isn't it? 8B, there is no 8B, 8, only 8 group, because there is no 8A, so there is no 8B proposed, but this is also 8B. Previously it was called 8B. So, these are called transition elements, isn't it? So, their characteristics we will discuss based on this modern periodic table. So, these are the groups in the modern periodic table. Look at here. Group 1 is called alkali metal, group 2 is called alkaline earth metal, and this middle one, look at it, these group B elements, which is indicated by the blue color, these are the transition metals, transition elements, and here are the boron groups, here is carbon group, here is the nitrogen group, here is the chalcogen group, here are the halogens, here are the inert gases. Like this, these elements are classified into different groups according to their features, according to their characteristics. All the halogens have the similar characteristics. All the alkali metals have the similar characteristics, isn't it? So, by this process groups are formulated. Here are the another group, inner transition elements are placed. The first series is called lanthanides, second series is called actinides, like this. So, in the modern periodic table, the groups are divided, groups and periods are given. Here are the altogether 7 periods. Look at here, horizontal rows are the period. And about the characteristics of the modern periodic table, let's discuss about the features of the periods. What type of period are there? Yes, out of 7 periods are named with the different nickname. Look at here, proposed name. The period of the elements, first period, only 2 elements, hydrogen and helium, isn't it? This period is called very short period. Nature of this period is short period. Second period has 8 elements. Second period and third period has the 8 elements, isn't it? 8 elements. You can see here in the periodic table. Look at here. First period has only 2 elements. Second period and third period has the 8 elements, which is called short period. These are called short period. Period 4 and 5 contain 18 elements. Look at it. Period 4, here are 18 elements. Period 5 has also 18 elements, isn't it? And they are called long period, isn't it? And period 6, look at it. This is period 6. Here are the 18 elements in period 6, and here are the other 14 elements. Look at it. 18 plus 14, or here are the 13 elements and 15 elements are in the down block, lanthanides block and actinides block. Lanthanides block has the 14 element, here are the 18 elements. So, altogether there are the 32 elements. So, period 6 and 7 have 32 elements, which are termed as the very long period, isn't it? These are the features of the period. So, elements are further categorized or divided into 4 blocks: S, P, D and F according to subcell electronic configuration. This is also feature of the modern periodic table. About the SPDF block we will discuss in coming class about this. And 15 element in each lanthanides, that is 57 lanthanium to 71 lutetium. Look at it, 57 lanthanium to 71 lutetium are called lanthanides, and 89 AC, that is actinium, atomic number 89 actinium to atomic number 103 lawrencium are kept in the F block. They are called actinides. Look at it. This first series is lanthanides, second series is actinides, which are placed separately down in the main block, isn't it? That block is called F block. Now, this is lanthanides, this is actinides, and these are S block. Look at it. These green color elements are in S block. This blue color element are in D block. Look at it. And red color element are in F block. So, elements are further classified into S, P, D and F according to subcell electronic configuration. Now, position of element in modern periodic table. In modern periodic table, elements have the different places according to their features or properties. Look at here. Nature and type of the element: alkali metal, alkaline earth metal, transition metal, metalloids, semi-metals, non-metal, inert gas, lanthanides and actinides. These are the nature of the elements, and their position is mentioned here. Look at your position of element in modern periodic table. Alkali metal are placed in group 1A or group 1 S block. Alkaline earth metal are placed group IIA, group 2. They are also S block. Transition metal are placed in group 3B, group 3B to group 2B, that is group 3 to group 12, that are D block elements, and metalloids or semi-metals are placed between group 3A and group 4A, group 6A, that is in P block, isn't it? Which possess characteristics of both metal and non-metal. Inert gas, non-metal are placed in group 4A to group 7A, that is in P block. Inert gases are placed in group 8A, isn't it? Or group 0. Group 18, that is also called group 18, which remain in the P block. Lanthanides and actinides all lie in group 3B elements, isn't it? and they are located in the F block element. Group 3b, that is group 13. Yes, these are the main features of the periodic table. And dear students, let's practice one exercise, one activity, isn't it? What activity we have to do? Look at your book. In your textbook there is given activity 14.3. Fill up the element below in the table from the atomic number 1 to 20. Also represent alkali metal, alkaline earth metal, halogen and the inert gases. Coloring the boxes separately. You have to indicate that which is alkali metal. You can show the separate color. Look at here. You have to fill here group 1A, 2A, 3A, 4A, 5A, 6A, 7A and 0. Here is hydrogen. After hydrogen, what will be there? Can you fill? After lithium, what do you fill? You try to fill here, isn't it? Lithium 4, 5, 6, 7, 8, 9, 10. Then 11, 12, 13, 14, 15. Similarly, go on filling up to 20. Atomic number up to 20, not more than that. Yes, this is the activity for you. You try to complete and you discuss in the class. You can show in your science teacher too. Now, let's practice some multiple choice questions. Choose the correct alternatives from the given. Here are some of the questions given. You have to choose the correct alternative. The first question is, what is called the element that belong to group IIA, group 2A in modern periodic table? Did you know? Yes. Is it transition metal, alkali metal, alkaline earth metal or halogen? What will be its specific name? Sure. You have found correct answer. Let's check it. Yes, it is alkaline earth metal. Alkaline earth metal lie in group 2A, IIA in the modern periodic table. Let's go to the question number 2. Question number 2 is like this. How many groups are present in modern periodic table? Try to think carefully. We have just discussed, no? Yes, 8 groups, 9 groups, 16 group or 18 group. How many groups are there in modern periodic table? Sure, you have already known the answer. Let's check it. Yes, group 18 groups. There are group 1 to group 18 in the modern periodic table. Now, let's see what is question number 3. Yes, question number 3 is like this. Which of the following indicates the demerit of the Mendeleev's periodic table? Which of the following indicate the demerit of the weakness of the Mendeleev periodic table, which we have already discussed? Yes, the first one is position of isotope was not fixed in the periodic table. Second is there are 7 period and 8 group in the periodic table. Third one is the element of the same features are kept in a group. The last one is some gaps are left for the future element. Did you find the demerit of the Mendeleev periodic table? Sure, let's check it. Position of isotopes was not fixed in the periodic table, that is Mendeleev's periodic table, which has weakness. Dear students, in today's lesson we have discussed about basis of classification of elements, and we discuss what is developmental phases of the classification. We studied about features of the Mendeleev's periodic table, Mendeleev's periodic law and its weaknesses also, and how modern periodic table was in the form of development. That also we discuss. We discuss about the features of the modern periodic table with groups and periods. This much for today. Remaining lesson we will discuss in the coming class. Thank you. Goodbye. Namaste.